Hello everyone, this is Karamo. So this video, I will want to present to you about missing values. So we are going to delve into a very important topic in data analysis, which is handling your missing values. Now, missing values is something that we face when we are working with real world data sets, and we can handle it different ways. But it's important that we handle these missing values properly because, as most of the data scientists would say, if you junk into your model, you're gonna have junk out at the end of the day. That's because your missing values in your data is not being managed effectively. So in this video, I'm going to use the mean or median to input missing values in all the variables we have. So we will have a diabetics data called MSSV, and we have only two variables. One of them is height, no missing values, but we have one which is the age got some missing values. So we're gonna see if we have to use mean or median to fill in these missing values. So why do we have to use mean or median? So the mean is useful when the data is normally distributed. That means it forms a beautiful bell curve shaped and it does not have an outliers or the extreme values. If all these two conditions are met, then we can use the mean. But if the data is not normally distributed, in other words, it is either left or right skewed, not symmetrical, or has outliers, then we can use the median to fill in the missing values. Alright, so let's go for to load the library we'll be used for this video. We will need tidy vars and we will need tidy error and cache. Don't worry about that. We have our data set is mssv.csv. Alright. So our data set is now loaded with only two variables and we have 500 rows we got in our data. Now we realize that we have two variables and height doesn't have any missing values. We can quickly check that out. So file. Let me write the code here. So we can have file and we want to summarize all. We want to summarize all and tilde dot na and all the variables. Now age have 50 missing values and weight does not height doesn't have any missing values. So but then we will now do a statistical test to see if these missing values in age have to be inputted using the mean or we have to use the median to fill in these missing values. But before that, first we have to check the class of our variable, supply, and we have file and class. Now age is an integer and height is so this video we are not interested in height because we don't have any missing values in it. So our interest is going to be on age with missing values. So because we're going to use a specific statistical test called the Shapiro-Wilk test, and this works best if a variable is numeric type instead of having it as integer. So we have to convert this variable from integer into a numeric type of variable. So we're going to have file and $sign we bring in our age as the numeric file and we bring in our age variable. So when we execute this line of code, we will realize that the data, our class for age is now changed from integer into a numeric type. So when we run this again, now age is now numeric and height is integer. But as I said, our interest is not on this variable because it has no missing values. The missing value is in age. So do we have to use the mean or median to fit in the missing values for age or not? That's what we're going to do. Now first we will now check for a normality test. So normality test that we're going to use is going to be Shapiro-Wilk test. So Shapiro-Wilk test is a function that is used to perform a statistical test of normality for a numeric variable. But the null hypothesis that we have to know in Shapiro-Wilk test is that the null hypothesis is that the data is normally distributed. So that means the p-value is, that means if the p-value is greater than 0.05, then we have to input the data with the mean. But if the p-value is less than 0 or less than or equal to 0.05, then that means we will use the median. So that means the data is not normally distributed. It's either it is left skewed or it is right skewed. So we will use the median instead of the mean to fill in the missing values. So now, after we've done the test, now let's now extract the p-value from H. So we will have an object called Shapiro 8, and we have Shapiro with test. Sorry, Shapiro.test, and Shapiro.test we have NA dot. We want to omit the missing values and final H. And now we want to extract the p-value from this. So p dot, let me just move this back a little bit, p dot value. Alright, so the p-value is now extracted. So it's worth knowing that if we copy this code and paste it here and run this line of code, our p-value will be generated. So the p-value for H is minus. So one thing I want you to understand is we have a negative value here. So then that means the answer for p-value here is not 9.18. It's 0.000 something up to 11 times 9 point something. So it's definitely less than 0.05. So that means we will use the median to fill in the missing values instead of the mean. Because in Shapiro-Wilk test, the null hypothesis is that the data is normally distributed, right? But after we do the statistical test, we realize that the p-value is less than 0.05. So we will have to use the median. That means the data is not normally distributed. It's either left or right skewed. If it is normally distributed, then that means the p-value is greater than 0.05, and we have to use the mean to fill in the missing values instead. Alright, so now what we are going to do now, we have to replace the missing values with mean. Median instead, because the data is not normally distributed. Alright, so what we're going to do here is that we will have another object, let's call it file1, and then we bring in our original data file. And then we wanted to mutate. I'm going to explain the code to you later. Let me finish writing the code first. So in mutate, we will have an age, and age is going to be is equal to if else is dot na age. Bring this back a little bit. Okay, so if else equals age, then if this condition is true or the condition is false, we will do a nested if else again, and Shapiro.age, the variable we created after we already extracted the p-value here. Then if this p-value is, let me create some space to make my code readable, is more than 0.05, then we will use mean to fill in the missing value. So that's age, and na dot remove is equals to true. Let me minimize this a little bit to fit the whole code in one line of code. All right, it's gonna be true, but then if else, we will use the median and age, and na dot, so closer, na dot remove is true, and then we have age. All right, so that's all we have to do, and let's bring this up to close our parentheses. So when we run this line of code again, all right, so that means our missing values are now being inputted without any error. So let's maximize this a little bit to make the code readable for you to see clearly what happens. And now if we go to a global environment here, we will realize that we now have two objects here. That is file and file1. And file1 is where our data is now being upgraded with no missing values. Now our original data is file, which is already here. This data original file got some missing values like data 0.5, 13, and we have 22 and so on. Now if we open the file 1, which is the data that is just been inputted, we realize that 5 is been filled up and 13 is also been filled, and we have the same number, 49 and 49. But we can ask ourselves, well, is the median because the data is not normally distributed? Now, if we calculate the median and see, so the median is here. So let's copy this code up to this point and find the median value here. When we run this code, we have, file and $sign, All right. So the median value here is 49. So that's because we got 49 from the median score. So that means that in the if else statement, the mean part is not applicable. Then that means the data is normally distributed. It's not normally distributed. That is, the p-value is less than 0.05. So then that's why we don't have the mean inputted. Instead, we use the median inputted. So, but let me explain to you the code one by one. First, let's start with mutate. Now we have our file. We create a function. We bring in our data file, which is the file from the original data, and we have the function. This is read as a pipe operator, but most people read it as and then. So that means we have our file, and then we wanted to mutate. Mutate means to create a new variable. So it is a function from dplyr package, which is used to add new variables or modify existing ones. So we wanted to modify these 8 variables, or to modify it. And it is also used to create a new variables. For example, we have 2 variables in our data, and we want to add another column here. For example, we can say this times this, and we have a specific column here to give us values of that. All right. So the second part of the code is that is.na here. So this is.na open parenthesis is a function that checks whether the values in the A column is missing or not. So if that statement is true, that if the missing values is if the value is missing in A, and false if the value is not missing. So this condition is going to check for us now whether the value is missing in H or the value is not missing in H. And if this is true, that the missing value then that means the code is going to continue here. But if it is false, then R is going to give us the original inputted data that we have there. Or else, so this code will continue on this nested if else if the missing value here is present. The code continues. But what happens at this latter part of the code? This part is a conditional statement. So a conditional statement here is that the if else function checks if the missing value is present. So this is true, and that is if the age is missing. So it executes the code in the first if else, which is the next nested check. So if it is false that the missing value is not present in A, then it keeps the original value of A. But in this part here is that if else Shapiro H, because in Shapiro H we already calculated the missing value. We already calculated the p-value, which has already been extracted from here. So if this p-value is more than 0.05, then we will input the mean score, because this mean age and everything here, this is going to give us the mean score. So that means this conditional statement is saying that if the p-value we generated from the Shapiro.h is more than 0.05, then the mean that will be generated from this calculation here will be inputted as the missing will inputted to represent all the missing values. But if this statement part is not true, then it's going to continue on to the second part, which is then we will use the median. It's like, well, if this condition is true, then do this one. Else, if this is not true, then do this one. So then the first statement here, which is Shapiro A p-value more than 0.05, it is not true, because the p-value we got is 0.0000 something up to 9 point something. So we realize that that value is not more than 0.05, it's less than it. So that's why this first statement is not true. Then we have to proceed to the second part, which is the median. So that's why all the missing values in file 1 outlet inputted with the median value, which is 49. Now, the common question that you might ask yourself at the end of this video is that, is it worth it to use mean or median in your missing values? Or how about you just remove your missing values, or you do some advanced techniques like machine learning way to input your missing values? Well, to my understanding, on my data analysis aspect, I think I would say it worth using mean and median, because using this mean and median, it's quite simple, it's quick, and it's effective techniques that can maintain the integrity of your data set, especially when the missing data is not too expensive. But we also have to bear in mind that it has some drawbacks. So while filling missing values with mean or median works well in many cases, It may also introduce bias if the missing values are not missing randomly or if too many values are included in the same column. So that is to say that, for example, we have age and the missing values is not just 50, maybe it's 300 out of 500. So you wanted to use a specific measure of central tendency like the median to fit in missing values like 49, 49, 49 for all the 300 missing values. So if you want to do a specific statistical test, the test result is going to be compromised because many values are very similar. So that's one of the drawbacks in using mean or median to fit in the missing values. But to overcome this, you can use the multiple imputation methods, or probably you can use the k-nearest neighbor imputations, and this might well suited in this kind of problem. So to summarize, I think both mean and median imputation are widely used, but the key is to ensure you choose the right one based on your data's distribution, because properly handling missing values can prevent data distortion and can also help improve the accuracy of your analysis. So now the choice is yours. Just make sure that you got the right missing value imputation method, and then there you go. Wish you all the best, and thank you all for watching this video. I hope you learned something from it. See you soon.